welcome to the seminars. I'm your new host. Ian's going to be back, and I'm sure if he can get away from the meeting, he'll join us halfway through. Just some housekeeping notes. As always, these meetings are recorded. You can find the links for them to the YouTube links on the videos. Especially, I do recommend, specifically with this week, if you have the time, watch the other sessions that we ran, because there were a couple of very good discussions we ended up having regarding the prototypes and the different ways we can develop our prototypes. So it might help you with your project as well. Then our next assignment that's due is the market research and the costing plan. So keep an eye on that. And we also had, speaking of the assignments, we had a couple of people asking us about the format for the final report and what you're going to, whether you need to follow a particular format. Ian posted something this morning on the discussion boards as a template of something you can follow. You don't have to follow that template as long as you're covering what you need to have in your report. And again, if you had more questions, you can email us directly and make sure to put Ian's name in the subject. If you have more direct questions regarding the actual assignments, so he'll get back to you. And he'll also update the discussion board with some more information about some of the templates you can follow for that report. Now, congratulations on completing your videos. I've been going through them, and I think I have about 20 more people left. Hopefully we'll be finished by the end of this week, and hopefully it will definitely be finished by the end of the week, and end of this week, and you're gonna see your marks showing up soon. Some of you would have already seen me commenting on the YouTube videos. Unless you had disabled comments on them, I would have emailed you comments directly. So keep an eye on your emails, or check it back on your YouTube video to make sure you can see my feedback regarding the videos. We had a couple of very good ones, so I'm personally very happy with that. And as a reminder, here's the mark breakdown that we have for the different assignments we had so far. And the thing that we want to get across is, from now on, this introduction kind of seminars are going to be more us trying to encourage you to talk about, especially about your prototypes, and it's going to be it's a good opportunity for you guys to ask advice from us and get started in some of the more questions you're going to have. And hopefully, as you move along creating your prototypes, or if your project doesn't have a technical focus and it's more of narrowing down the requirements and the types of sensors and the specification you would need if you then go on in the future and implement that design. So this would be the best time for us to kind of catch up on that and have discussions. This week I'm gonna kick off those discussions, give a quick talk about sensors. Again, very, very general overview. And by now we should kind of start narrowing down who would be the best person to kind of talk you through the project. And if you wanted to get some more advice, that doesn't mean if you choose one of us, then you're only limited to just talking to that one person. If your project includes multiple different things, you can always contact us through that IoT capstone email. If it was specifically to do with some of the other electronics, embedded system, choosing your platform, types of sensors, so the embedded system side of the IoT device, I'd be the person to ask. If you had more specific questions about the networking protocol and communication through the network of your IoT device, either Ian or Naz would be the best people to ask. Anything to do with AI, Hannes would be your guy, and of course, anything to do with big data and cloud computing, Valerie would be able to help you out with that. So you can find a list of the faculty on the WebEx page. So try to find the best person be able to help you out with the project. And when you're emailing us with that capstone email, just put the name of the person who you want the email to go to in the subject line so they can get back to you sooner. And so we'll finish in week 12, but we're going to keep running the MOOC for two extra weeks to kind of finish marking your final reports and give you additional feedback on it. And as I said, we won't have any more official sort of seminars. We're running these sessions as more of a kind of encouraging you to talk to us and get our advice and kind of get a discussion. All right, so again, get things started.
Yes, they are.
All right, okay, cheers. All right, so let's have a very quick overview of what sensors are. So basically, with electronic sensors, depending on what sort of component you want to calculate, whether say it's temperature, pressure, movement, there's usually an electrical component, a change in an electrical component that we are measuring. And then we look at the data sheet and convert that change of the measurement and the changes of those electrical measurement to an actual real life characteristic like a temperature or pressure. So with that said, we're going to divide sensors in two main categories. We have active sensors and passive sensors. If you are so when we're talking about raw data from a sensor, those are the changes that we are initially getting from the sensor before converting it to something else. If we're talking about active sensors, we're measuring a change in current, voltage, or impedance. So those are considered active sensors. And passive sensors, if you're if you're doing current and voltage, those are active. And if you're doing passive, you're calculating passive changes like resistance, capacitance, and impedance. Those are your passive sensors. So as an example of some very useful sensors, I have three examples here. So the first one is an FSR or force sensitive resistor. As you can see, it's a very easy setup. I have the code for it for an Arduino. Basically, you connect it up, you put a variable resistor there, and you can read the pins that are connected to your input-output pins of your microcontroller and pass the information through a serial monitor. A couple of people asking us whether these are good for kind of measuring steps or calculating a gate, the way someone moves. The problem with kind of using these sensors is they're not that sensitive to those movements and they're very prone to lots of background noise. So it's better if you use these in kind of conjunction with a more traditional motion sensor like an accelerometer or a gyroscope as a background support of that. Have someone working on an idea here at Curtin at his thesis where he's built this sort of inlay thing that he puts on a bunch of these sensors and puts them in someone's shoe and able to detect steps, but he's that alongside an IMU sensor, which we're going to cover in a second, and how it's kind of using that in conjunction with an IMU sensor, not as a standalone sensor. Another very typical sort of sensor would be a temperature sensor or a humidity sensor. The one I have over here, it's a TMP36. It's a very basic, very easy to use temperature sensor. It basically has 3 pins. It has a voltage, ground, and a signal pin. You connect that signal pin to your micro, you get the information that's coming from that pin, and you see you'll find an equation like the one I have here on the slide to kind of calculate that change in voltage to actual temperature. So this is how we're setting it up. Again, very simple setup, connecting to the micro. And very simple code for it, where you initialize the pin that's connected to that signal pin of the sensor. You start your serial monitor, you read the information as an analog read to the pin, convert that to temperature, and you can display that in your serial monitor. Once I'm done marking the videos alongside AAE and our other faculty advisors, I have a bit more time, I'll post some of these codes and links on the discussion boards. And after our quick talk today, I'll show you some of the ways I usually go about kind of starting to work with a new sensor that I haven't worked with before. So to give you an idea of where you would start, have a sensor and you have a micro and we want to kind of get started working with it. Now, Ian's favorite sensors, IMUs, are basically an accelerometer, magnetometer, and a gyroscope embedded on the same package. Sometimes like the accelerometer and the gyroscope are a bit separate in a separate package, and they have the magnetometer on the same. The reason these sensors are very useful is you have the accelerometer, and the way the accelerometer works, it measures the linear acceleration in 3 different dimensions. If you do some trigonometry calculations, like the ones that I'm showing over here, you're able to get yaw, pitch, and roll, so which is basically all of the orientation you would need within a movement. And with the gyroscope, you can get angular momentum or angular velocity, which gives you more of the rotation, and because it has a spinning rotor inside of it. So, and again, that gives you the motion in 3 different directions. It gives you a very good estimation of movement without needing to use expensive motion capture cameras. We actually had a PhD student do his final presentation yesterday who used these sensors with foot drop issues, and comparing the results from capturing information from IMU to a $5 million setup of a motion capture analysis lab that we have here at Keratin, because they were very specific, just calculating the steps and the way whether the patients were dragging their feet or not, it was very comparable. So instead of using that much money, she pretty much ended up capturing the information by, I think, because she had 3 sensors, so at most under $100, including the 3 sensors and the receiver she was using. How are we doing on time? Still have a bit more. So again, and I'm personally not using the magnetometer in my own thing. So I'm using these sort of sensors. I'm going to show you in a bit to capture wrist movement, and this is specifically for children with cerebral palsy. I'm doing that as part of my own PhD, and I'll calculate that movement, and afterward I'm post-processing them, machine learning on them to kind of find the characteristics that would show up there. Magnetometers tend to get very noisy, especially when you have very prone to magnetic interference. So I don't use them, and I don't really need to, because I can get the rotation and the pitch and yaw just with the accelerometer and the gyroscope. Before I get to some examples of using IMUs, just a quick kind of sidetrack, looking at the concept of signal conditioning. So with of these sensors, the raw signal you're getting from the sensor, it does need to be processed afterwards. So you need to, before you actually able to process it, you need to make some slight changes to it. That's what conditioning. 3 main examples. That there are more signal conditioning things that we can do, but 3 of the more, I say, useful ones are linearization, amplification, and filtering. And I have some before and after pictures, so you guys can get an idea of if we have, say, a nonlinear signal, how would it look like if we did linearization to it? If we had a signal that we wanted to amplify to kind of make it a bit more clear, so we can give it a bit of a gain, see the data more clearly, and probably the most important one, filtering, which is the main thing and the challenging, usually the challenging bit, especially when dealing with IMUs, is when we are going to filter out the noise in the signal. Say whether we want to use a low pass or high pass filter to filter out any of the unwanted bits of the signal. That's why we get to filtering. Now, as an example of some practical example use of IMUs, something that my wife's actually working on. It's an IMU sensor. It's a 9150, which is she's now using 9250. Connected to an Arduino Pro Mini, a Bluetooth transfer module, and a battery pack. And she also has an Arduino Uno connected to a receiver to kind of receive these signals. So what she's using it for is she has the sensors connected to a wide gain and a leg to remotely track gain for a remote training system for people who have who are visually impaired, and because they need to learn how to use these sensors. And if they live in a remote area, it's going to be very expensive to fly trainers there to help them. So you're remotely tracking the movement and then giving feedback to the trainer from somewhere else, and kind of that's how she's building her training system. So this is the one that I'm working on. Halfway through a prototype before getting to an actual working product, because the red board you see here, that's an RF transmitter. The blue one, that's the old version. That's a 9150 IMU MPU 9150. I'm using the newer one right now, MPU 9250. And the green board that you see, that's the customly made Arduino Pro Mini. So because these sensors are used on babies and infants, we needed the sensor to be smaller. So that's why the older generation, when we had other PhD students working on the project, that's how far they got. They kind of reduced down the size of the microcontroller, and they ran out of time, so they kept the IMU and the transmitter the same size and kind of sandwich everything together to that. And showing you the ugly receiver is just literally an Arduino Uno sticky tape to receive the signals. A couple of people ask me, how do you usually capture signal prototyping? So this is a very simple program, serial port reader writer, and it's have some wireless communication, and you just want to quickly get some data to your laptop or something. It's off a serial port of your laptop or your computer. It acts like a serial monitor. So I have my receiver connected to my laptop. I'm reading the information. I can pause the data coming through and save it as a CSV file, so I can then feed it directly to MATLAB to do my processing there. And as you can see, I have a sensor ID. I use two of these sensors, one at the back of the hand, one slightly above the wrist. And so that's why I need to have the sensor ID. There I have a timestamp and the data from the accelerometer 3-axis and the gyroscope 3-axis coming through. And I'm not any processing on Arduino at all. I'm doing my the moment is all post-processing. These are all raw voltage data coming from the sensors. These are not actual acceleration or angular velocity. Later on, I'll do that alongside my filtering and noise cancelling on my MATLAB algorithm. And as an example, this is how kind of comparing a normal movement versus someone with a palsy, and the trial was a simple stop sign trial. So trying to hold your hand as right of an angle as possible. So if you see the left diagram, the maximum angle is about, so this is angle versus time. It's about 25 degrees versus the other one, which is about 80 degrees. And so cerebral palsy is it's a muscle movement issue and muscle movement disorder. So the maximum angle that someone that doesn't have cerebral palsy can kind of move their hand is going to be different with someone who has palsy. So that's because I'm using this to kind of try characterize palsy and non-palsy patients. So visualization of it. And some more diagrams showing you what the data from IMU can look like. Simple tests of showing acceleration in slow movement and then slightly faster movement of a wrist. And of course, slightly slower movement, which I specifically included this here because it shows one of the biggest problems with IMUs because they tend to a lot. So especially if you look at the z-axis, you can see a very big drift coming through. So that goes to show the importance of having those signal conditioning filtering options when we're dealing with these sort of sensors. And the next step, which is what I'm currently working on, is now going from that prototype idea of everything being sticky tape together to an actual project, to an actual product where I have a microcontroller and the IMU sensor and the transfer device all on the same PCB. And then I'm also, instead of having another Arduino and capturing the information through my laptop, I'm building a phone app to kind of capture that information through the phone app and do the processing later on using cloud. So this way, this now becomes an actual product rather than just a proof of concept. Well, hopefully it becomes a product once I actually get it. Now, before I move forward, how about we take a quick pause in the discussion to get to some questions, and then I'll continue. I saw there was a question coming through at the beginning. One video presentation, can I recreate my video and upload again? It has really bad video. Well, you can send us the link again, but we might have already marked it. We wouldn't have, at least for the ones I remove any points or any marks if, say, the audio quality was bad. I'm more interested in the content and the way the material was presented, but a bit past the. I would recommend maybe sending an email to us through Capstone and putting Ian's name in the subject line.
I will do it. Thanks.
All right. Any more questions so far? I'd love to hear prototypes. If there are any particular problems you've been having, I could possibly give you some advice. If you're having any issues with the platform you're choosing, to hear what sort of platforms you're using. Are you using Arduinos, ESP32? You can use that raise the hand feature next to your name, and Hannes will unmute you so you can speak, or if you prefer to type your question in the chat window. Right, so maybe to get the conversation going, I'll show you a couple of more interesting things. So this slide that you're seeing over here, this is a different approach to kind of designing these prototypes. John, I'll go through these slides, John, and I'll get to your question. So with these ones, they usually offer a bunch of sensors. So this specific one, as you can see, it has a temperature sensor and ambient light sensor, all packaged PCB, and they usually offer them in small packages. And they usually come with a phone app as well. So these could be good starting points to play around with some sensors and kind of get an idea of what an app interface looks for these. And here's a look at the app interface for one. This is a sensors tag from Texas Instrument. And another one that's a bit more interesting is Nordic 52 Thingy. As you end up for these sort of development modes, you'll see that engineers tend to like to the use of word thingy in the names for some reason. So this one, it has a bunch of other types of sensors, and it's a bit more robust. The software for it is a bit more robust. There's a microphone, there's an LED there. Now, the reason I'm mentioning these types of products is for it. That picture you see at the top of it, that's a 3D model of the actual sensor. So if you move it around using the IMU, they have built-in kind of showing a 3D representation of the movement. Now, the reason these can be interesting is even though they're slightly more expensive as a development kit, they offer they offer like these two specific ones. They offer the PCB design for their whole board and the source code for their phone app. So say you wanted to work with a specific sensor type and you like these guys' app interface, you can get an idea from their PCB, design your own PCB, and get rid of all of the other sensors that you're not using. And because they offer the source code for the app, you can modify that and then have a working app slightly quicker if you run and design everything from the ground up. And they do offer, and there's a good community around these sort of devices. As I said, they're slightly more expensive, as let's say compared to like a traditional development board with a bunch of sensors on top of it, but could be an interesting way to kind of approach the design. All right, so let's get to some questions. Part of the issue that I'm having is about time, just making the time between projects because we're on prototyping. Yeah, so that's fine. Of course, we'll be more happy if you have working prototype, but everyone who's doing this course, not everyone has that technical background. Even if you end up having a very detailed list of the requirement and specifications of your device, that's going to be a very good report. And I don't know if you've seen my comment on your video or not. It really worked well as a proof of concept, and you went into some good details of what your idea is supposed to do and why it's useful. So it was very good. Now, one more question. Why I don't have right comment? That's fine. Let's see. What software do you recommend to PCB design? Now, for actual design of getting to a product, Eagle is a good software, and it's free, so you can download it. If you're looking for something more professional, there's Altium Designer, but it's a paid. I don't know if it's subscription based or there's like a license you buy for a year. But I've been using Eagle a little bit here and there, and it's been working fine. I haven't had any big issues with, say, like anything that is available in Altium compared to that. Because it's free to play, there's a bigger community. It's free to play. It's because it's free, and there's usually a big community around it. So I would recommend that. And there was this other software. Let me share. That's more for simulations of boards. Let me find first and I'll share the link. That was for MT250. So, right. So, Fritzing, that's more for kind of simulating your sensors and microcontrollers with the sensors, but there's that as well. But if you're very interested, like if you're keen on working specifically on PCB design, I highly recommend Eagle. All right, so more questions. Someone has posted something on the discussion chat for people who are interested. How about I share the screen? Kind of all together. Right, yeah, Nordic Thinking 91. I think that's their like updated version of the 52. Let's see, yes, it's easy to use. Oh, they have LTE. on there: air pressure, air quality, humidity, temperature. So if we click on get documentation, what sort of stuff it show us? While that page is kind of loading, let's see, still loading on my end. While that's coming, one thing that I usually use, especially if I want to use with a popular sensor like a TMP36 or an MPU 9250, which is a popular IMU. This site, Core Electronics, a bunch. So it's a retailer, but not mentioning it so that you would go ahead and purchase stuff from there. My recommendation would be, especially if you're working on prototyping, you can go to AliExpress and find a cheap one, cheap Chinese one from there, and then their kind of tutorials. So you can see usually underneath their products. So here's, say, like looking at 9250. They have a more detailed version of the datasheet of the sensor. So this is the IMU. More characteristics of it. They talk about sizes. They show how you would hook it up. This is a hookup guide for a Arduino Pro Mini, and of course, pins you would need to solder to it. Hook up the guide, and my favorite part is they actually do and offer lots of example codes to get some tests going on. So this is where you would usually start. If there is a that I want to work with, I first look to see if any of the popular manufacturers like SparkFun or have any breakout board for it. And if you don't know what a breakout board is, it's essentially a sensor itself on a piece of breadboard with pinouts accessible through the holes over here. So you can just solder some pin headers to them and connect them, play around with them on a breadboard. So I look to see if any of these popular manufacturers offer pinouts, because if they do offer pinouts, then you're gonna see lots of useful open source kind of starting guides for these sorts of sensors. So Adafruit, SparkFun is another good one. So any more questions? Be set up at the end of the course. So the question for everyone are we expected to have a working prototype by the end of the course? Not necessarily. We would rather you get started on a working prototype, even if you don't have a technical background, because, well, as an engineer, they're interesting to us. But if you don't have a technical background and more looking at more of project management side of IoT, you can end up writing your report based on narrowing down the sets of the specifications and the type of sensors and communication protocol you're going to and that I'm personally interested in seeing prototypes. I've already seen good ones, videos. My favorite one so far has been it was in the group that we had this morning, the idea of a smart shower head to kind of water, and there was a working prototype. And of course, we have two of the ladies here working on similar ideas to mine, IMU sensors tracking movement of children with cerebral palsy and building reward systems there. So say if they needed to do some exercises at home, kind of encouraging them to do the exercise more by music and sound. Think of it as a more specialized Fitbit specifically for children with cerebral palsy, because for finer movements we need to track. So some of the I've seen so far in the videos. So, another question. My project is smart sorting bin using Raspberry Pi camera as sensor. I think he's talking about his project. So he's using a Raspberry Pi camera as sensor, micro, AWS cloud. Which connectivity should I use, LoRa or 4G? And I have to use a battery. Where I would say if it is an issue, probably 4G would be better rather than LoRa, because LoRa usually works better with short ranges. One more thing I would say, if we wanted to get some information about LoRa, LoRa shield. So this is an Arduino LoRa shield for Arduino. It's not for Raspberry Pi, but you can some good documentation for it. So to get something going on, like set up something, it could be useful. There's also this other one. These are very popular. So ESP32s, which I've already seen lots of people mentioning them in their videos. ESP32 LoRa, like this is one from AliExpress. There is an ESP32 or the older generation. I always forget what number it was. 8622, I think it was. So these are popular because they have a Wi-Fi module and a Bluetooth module embedded on the same micro. Offer an Arduino core for it, so you can just program them using Arduino and Arduino's programmer. So even though they're not Arduino ESP32s, there's an Arduino core for it. And I've seen lots of these LoRa modules paired with ESP32s. Again, I know you're using a Raspberry Pi. The reason I'm mentioning these is because there are good documentation around these devices. So if you wanted to test LoRa, I'd recommend taking a look at these solutions to see whether that would fit within what you're trying to do. I hope that answers your question. Okay, so another question from Anton. Use software simulation also, something like Pro Tools? Yes, I definitely use specifically for Pro Tools, especially when I'm getting if I wanted to test a circuit, because with Pro Tools we have these nice oscilloscope modules. I haven't used Pro Tools in a couple of years because I've moved to using PSpice because we had access to it Keratin. Know how the licensing for Pro Tools works these days, but yes, I do use a couple of these sort of circuit simulation softwares. I want to just quickly test the circuit. It's much faster to simulate it rather than build the circuit with the wire on a breadboard and then use an actual oscilloscope. All right, so another question. I'm having to learn a lot as regards my project idea, and I'm not sure I will have all the requisite knowledge by the end of the course. So, well, that's why we are here in a sense, so we can kind of guide you through the right pathway to kind of getting leaps in your knowledge, like getting there a lot faster. Maybe told us what your project is about. I can maybe tell you who would be the best person to kind of get in touch, so they can offer some resources. So while you're getting back to us, John has another question. Less important, do you have advice about shells or cases that can use to keep the MCU sensor protected and organized well while we test? Not really. Well, I use a lunchbox to kind of hold my receiver, but a very good cheap option, especially as a prototype, is something that Ian mentioned the other week, are 3D printed cases. There are also online that you can upload your printed design and they'll print it for you and ship it to you. They're not that expensive, and because the material they use is cheap, so good options. There's another question. I did email reply. If you haven't received any reply to your emails, as always, if it's been more than 2 days, send that email again or forward it again and put the name of the person who's using it in the subject line, and I'm sure they'll get you. It's been a really busy week at Keratin. I promise it will be better. So we had about 10 minutes. Anything else? Yeah, I'd be interested if for the people who have started kind of on their prototype, I've seen them in the videos for your friends, for your guys to see what sort of you're working on. The name in the chat might be something that would be of use to other people as well. I have a couple of email again thinking about what platform to for their projects, and as always, I'd always say probably the prototype, the cheapest one, Arduino would be a very good option because it's cheap enough and it has a big enough community around it, and started on a source code with on an example code with Arduino is very fast. So, and because that's why there's such a big community around it, because lots of the setup you would need to do with a microcontroller have to do with setting up, say, internal registers and memory, and setting the direction of the pins as inputs and outputs, managing your memory. So if this stuff with Arduino is abstracted out, your focus is more on pure interaction of your microcontroller and those external sensors. So that's why I always tend to suggest Arduino as a device. These days, I've heard very good things about ESP32. The problems with ESP32s is they're fairly power hungry. If your device is portable, that might be an issue. Of course, there's a Raspberry Pi, especially with the new Raspberry Pi out. Could be, and again, kind of a platform. I would tend to stick some of the more commonly used ones first, and then when you want to actually take it to a more work, like that's where I would look into choosing a more specialized microcontroller than a Raspberry Pi, or something that can maybe, if it's something that's a bit more secure, something with slightly more computation power. So I wanted to get you comments about the hardware for my project. It's about to track the electric scooter.
Right, maybe I can explain a bit more if you can hear me.
Okay, yeah, sure, go ahead.
Excellent. So the problem first is that scooters are driving, people are driving, some of them are drunk, some of them are too young, and the speed of the scooters is not really properly regulated, and sometimes we are driving more than 45 kilometers. Imagine that pedestrians somehow trying to survive, and so on. So far I got an idea that we would like still to have a kind of a tag which we can put on each device, on each scooter, and later have a little network, let's say in a town, which will be able to identify the scooter. And that tag I thought to use something based protect on ESP32 using exactly Bluetooth. So sending this data, and on the receiver side as well, actually, ESP32, which they will be used to identify ID of scooter or owner, and then later throw this information to the cloud. But I'm trying to imagine, let's say, amount of scooters around, and let's say these little boxes with ESP32 will be placed with probably distance like 15 meters to identify up to, maybe scooters in parallel and get this data. And yes, the question is exactly, will you suggest going with ESP32 for such task?
Yeah, I do, because especially maybe after, let's say, if you wanted to make it an actual product and you end up seeing battery consumption is a big issue for you, you can alternatives. But as for what you're doing, I think ESP32 would be a very good platform, especially again because then it does have that Wi-Fi module in there. There are very good stuff that people are doing with ESP32. I would say stick around with ESP32. That's a good option.
And the second question: do you see how you see will it be really hard to identify, let's say, so many scooters, let's say short distance, like radius like 50 meters, let's say 10 scooters, passing and so on. Maybe some problems that you see already, which
not off the top of my head. Are you thinking about like detecting if there are a couple of scooters moving alongside each other?
I'm trying at the end to be able to identify even speed. So basically, let's say, yes, we have lightings on the streets, and this lighting has actually electricity, and I thought that ESP32 will be able to get a discussion with our town management, basically, to get the electricity from the lightings. And the idea is to be able to identify the speed. So if I see that one scooter is bypassing like with speed like more than 25 kilometers, then yes, right, this is a problem already.
I see.
But question is, that there will be not only one scooter, there will be more scooters plus as well. People with phones, we have as well Bluetooth enabled stuff, so I need to sort out things somehow. So the second question is, maybe you see some technical hard advantages of it.
Oh, maybe if you send us an email with a bit more detail about that specific question, and put my name and so I'm COH by the way, and Ian's name. I will look at some of the a student who's kind of working on a smart, it's not a scooter, but on a smart skateboard. So he needs to kind of track if there are any solutions that maybe would be of interest to you as well. Another thing I would say specifically with ESP32 is because they have started offering it dual core models of it as well. So it actually has two cores, the processor. So it tends to be a bit more powerful compared to the same sort of micros and same price range. So definitely like sticking with ESP32, especially since you operate the real-time calculation is going to be important for you as well. And in case, say, your internet connection drops out, catching up with that. So, and I would say if you end up implementing this idea, I see a very great potential of its use case. Especially I've heard scooters have become very popular especially in around the San Francisco area. So maybe get to an actual product, you can to the companies that are renting scooters as a way of kind of monitoring the scooter movement. So, and since how popular they've gotten these days, and from accident, as you know, you're doing the research on it, it would put kind of a market out there for it.
Thank you. Right, exactly. This was like a plan as a second market for this project.
Yeah. Okay, no worries. All right. Thank you, everyone. We've had a discussion there going. 3-4 more minutes. If everyone has any quick questions. We're starting to do wind down here. Again, email with your questions. Any embedded system type question, microcontrollers, net type questions, AI questions for Hannes, the big data, cloud computing questions for Valerie. Let us know. And we are going to the videos, and they're going to be, you're going to see the marks posted by the end of the week. So again, take a look at, if you haven't locked off comments, I would have emailed you comments and the other instructors as well. The videos had comments disabled, they would have emailed you with their comments, or otherwise you would have just posted a comment directly under the video. And I guess as in comments, specifically with these sessions that we ran this week and last week, I do recommend, if you find the time, having a look at the recorded videos for the other sessions, because there were a couple of different sort of discussions that kind of came up. So Anthony has raised his hand. If you have quick questions, we have a minute.
Still from before when he was talking.
All right. Okay. Good then. Right. Thank you again, Hannes, for the help. Coming to the rescue.
You do all the hard work. That's just the way I like it. Good evening, Suvash, and good luck to you all on your projects.
All right. Thank you. We're at 9 o'clock. So everyone, have a good rest of the day, and we'll be in contact through email, and I look forward to looking at the rest of the videos. Very interesting.